Hello and welcome to another edition of Digital Learning. Today we're going to take a look at the basics of probability. So we're about to go into a probability topic, and you can go so deep into probability, there's so much to know. So I thought today we could start off with some of the basics. If we could get these down solid, then we will be good to go for tomorrow so we can go a little bit deeper, take it to the next level. Right, can you please pause your video and write the following down? All right, let's take a look at what you just wrote down. So whenever we're talking about probability, essentially what we're doing is we're talking about the chance of something occurring. Now, probability is calculated to be either a fraction, decimal, or a percentage. That's how probability is measured. And the way you can calculate probability of a single event, so this would read the probability of an event occurring would equal the desired event divided by the total amount of possible outcomes. So you would take the amount of times that event occurs, divide it by the total outcomes, all the possible outcomes that could occur. Now here's a scale, so it's called a probability scale, and whenever you do the following, so whenever you divide and get your calculation, you might get 1/2, 1/3, 2/5, so you're going to get a different fraction every time. And what you do is you can then come to your probability scale and see how likely that event you can see how likely that event is to occur. So for example, let's take the classic. I want to find the probability of flipping a head on a fair coin. We know there's only one head out of, and all of the possible outcomes are either heads or tails. So there's two possible outcomes. So the probability of me getting a head on one flip of a coin is 1/2, and that lands here right in the middle of the probability scale. So what you'll notice is 1/2 is in the middle, which means there's an even chance of me getting a heads or a tails. That's why everyone flips a coin to decide things, because it's at least same chance of getting either. Now, if something had a 0 chance of happening, that means it's impossible. There's no way it could occur. If something had a 1, so the probability of something occurring is 1, that means it is certain. It must occur, has to happen. Now, if you notice, this scale is a fractional scale. So for example, over here might be, so I could have 3/4, and I could have 1/4. So all the different types of probabilities lie within this scale. Now, like I said before though, probability can be measured as either a fraction, a decimal, or a percentage. So what I want to do is I just want to show you what this scale would look like if we did, say, percentages. So for example, say I wanted to write the probability of me getting a heads as a percentage. So we know that equivalent would be 50%. So this scale would look something like this. 50%, this would be 100% must occur, and this would be 0%. And again, the third one would be a decimal, so we could also say this is equivalent to 0.5. All three of these values are exactly the same. Sorry, I want to change that 5. That's not very nice. There we go. And then the scale would look something like this. So that would be the percentage, the fraction, and it would be 0, 0.5, and 1. So there are the three ways you might see a probability scale. The first skill set is to be able to describe the probability that's occurring, so using words. So you're going to be using words like impossible, unlikely, likely, certain, and then the next would be to calculate, and that's when we're looking for the actual numerical value of that event occurring. So let's go through these two. So the first skill set we're going to talk about is describing. So if in the instructions you read describe the chance, or use words, something along those lines, you're looking for answers like certain or unlikely, etc., etc. If you see something that says calculate the probability or find the probability, that means you must actually physically calculate it by taking that equation we just took a look at. So the probability of an event occurring, you're going to get the desired event that you just wrote down, and you're going to divide it by all the total possible outcomes. So this would be 1/2 or 3/4, etc., etc. So let's take a look at two different examples based off of these two skill sets. So let's take a look at this example. Take a second and pause the video to write this down. I'm going to do A and B and see if you could do, actually, you know what? I'll do A, you'll do B, we'll do C together. Okay, so Rory takes a ball from this bag. Describe the probability, there's that word, describe the probability of taking, and I'm going to do this one first, a red ball. Now, because this word describe is there, the answers we're looking for are something like this: impossible, unlikely, even chance, likely, or certain. So first we kind of want to actually calculate the probability of getting a red so that we can see where it falls on our probability scale. So the probability of getting a red, if we were to actually calculate it, let's do that. Well, how many red options are there? 1, 2, 3. So there are 3 possible reds out of a total of, if I were to, so what's the situation is we're going to take our hand, Rory's going to take his hand, put it in his bag, and take out one ball. And we want to know what's the chance of that ball he takes out being red. Okay? So far he has 3 reds he could pick from out of a total of 6 balls. So if we were to simplify this fraction, you'll notice that they both have a common factor of 3. It simplifies to 1/2. So there is an even chance of him selecting a red. So we would describe by leaving our answer as even chance. Can you please do something similar and find me B? Pause the video. All right, let's see if you got it. So first of all, let's do like we did before. We'll find the probability of getting a yellow. So how many yellows are there? There is 1 out of 6. So you didn't have to simplify this one, so hopefully that's what you got. But you did not leave that as your final answer because you must describe the probability. So if I wanted to describe the probability here, 1/6, well, we know this is 1/4. So 1/6 would be between 0 and 1/4. So we would go with unlikely. Hopefully that's what you put. Can you give yourself a red tick if you did? And let's take a look at this last one together. So this one says, find the probability of getting a green ball. So what you notice about this is there are no green balls. So when you go to find the probability of a green, there are 0 greens out of 6. And look, you know that 0 divided by anything is 0. So there's a 0% chance. So if you were to describe green, oh no. Oh no, sorry. Okay, if you were to describe green, it would be impossible. There's no way Rory would go into this bag and pick a green out. All right, I want to go over a couple more examples. So can you please copy these 2 down and one of these spinners? Pause the video. All right, for this regular 7-sided spinner, write the probability of the spinner landing on a blue. So if you notice the difference between this question and the last one is it doesn't say describe, it says to write the probability. So we actually need to calculate it. So if we want to find the probability of blue, we want to know how many blues there are out of the total outcomes. So first of all, we were told it's a 7-sided spinner, so we know there's a total of 7. So out of 7, how many blues are there? 1, 2, 3. Can I simplify 3 over 7? Doesn't look like it because they're both prime numbers and they don't have a common factor of either prime number. So my final answer would be 3/7. Can you pause the video and find me this one? All right, let's find out. So you were trying to find the probability of green. So first of all, you're trying to look for how many greens there are out of the total. So how many greens were there? There were 2 greens out of 7. Yours can't simplify either, so you were done. Perfect. So this is the difference between calculating or writing the probability versus that word describe. So describe, we're looking for worded answers, just like you would describe a person or describe a food that you just ate, right? Versus write the probability, so calculate it. We need numbers. The last one I want to do is this one. Can you please pause the video and write these 2 down? I use the same spinner, so no need to copy the spinner. Okay, so write the probability of the spinner not landing on a red. Okay, so there's a couple ways we could do this, but first of all, let's just break this phrase down first, of not landing on a red. So we know that probability is on a scale from 0 to 1, right? So if I were to actually list all the possible outcomes, right, we know there's 7 of them. So we know that the probability of this event occurring will be out of 7. But the question is, what goes in the numerator? So the first thing we're thinking, if it's not red, it could be anything but red. So what we would do is we would count all the rest up that are not red. So 1, 2, 3, 4, 5, 6. So the answer to this would be, hold on, sorry, I forgot to, hold on. There we go. Probability of not red, sorry, that's better, would be 6 out of 7. Now there's another way you could do this. What you could do, if this is easier, is you could do 1 minus the probability of getting red. Because we know the probability is measured on a scale of 0 to 1, 1 being all the possible things that could occur, right? It's certain, they all must occur. If I take the probability of red away from 1, I'll be left with the probability of not red. So for example, if you do 1 minus the probability of red, the probability of red is 1 out of 7. So 1 minus 1/7 is 6/7. So you end up getting the same thing. So there's 2 ways you can go about it. This way you might find simpler. This way might help you when we get to the more difficult questions. So that's why I want to introduce you to both. Can you pause the video and try this one for me? All right, let's find out. So not yellow. So anything but yellow. So the probability of not yellow. So you notice that there's 1 yellow. So again, you go 1 minus 1/7, which means you're left with 6/7 would be our answer. Or you could have just counted up the ones that weren't yellow and put it over your total. Perfect. Now, after you're done doing this, if you want, you can go back and watch my video, or you're about to log on to Heggetty to do your independent task. Why not watch Mr. Heggetty's videos if you're still stuck, or send me an email. Good luck.